a weak acid is reacting with a strong base. A weak acid we're going to represent as undissociated because that's how it exists primarily in solution. The strong base here is going to be represented as hydroxide ion. So our initial reaction is that we have this weak acid reacting with a strong base. The products are the conjugate weak base plus water. We have an initial amount of our weak acid of 4 millimoles. We've added 2 millimoles of our strong base. So the hydroxide ion is the limiting reagent. It's all completely consumed. In the process, it is consuming 2 millimoles of our weak acid, so that 2 millimoles of our weak acid remain, and we're producing 2 millimoles of the conjugate weak base. Therefore, this is a buffer. In solution, we have some amounts of a weak conjugate acid-base pair. Specifically, in this case, we have HNO2 and NO2-. The Henderson-Hasselbalch equation applies, so we can get a numerical value for pH as a negative log of Ka plus the log of the ratio of base to acid. Since these exist in the same solution, the ratio of moles is equal to the ratio of the concentrations. Here we have a balanced buffer. We have an equal amount of our weak acid and its conjugate base. That means when we're determining a numerical value for pH, pH is equal to the pKa.